Exercise 1437 is asking you to write the balanced chemical equation for the ionization of each of the following amines. And they give you a couple here. They give you methylamine, and we'll also do dimethylamine. And you don't have to worry about C, so that's not applicable for us. So we're just going to do these first two. Ionization is a process of gaining charges. An ion is an atom or a group of atoms that has a positive or a negative charge. So what we're going to be drawing is we're going to be drawing these amines gaining charges when we put them in water. Ultimately, the amines are going to be acting like bases. Amines are bases. And that's pretty important because amines are really common in neurotransmitters like dopamine or serotonin, and in hormones like adrenaline. And part of their behavior, the behavior of those hormones and neurotransmitters, has to do with the amines on them acting like bases. So let's see how that works when you just put amines in water, sort of like the simplest possible scenario. Now the first thing we have to do is to draw the amine. The first, start with the backbone. Amines are named a little odd. You'll notice the ending of the name is always amine. And that amine is referring to a nitrogen. Now usually the nitrogen has 3 bonds and 1 lone pair. You'll remember that you can draw the Lewis dot structures of things like of atoms by looking at what column an element is in the periodic table. If you look, you'll see that nitrogen is in group 5a, so it has 1, 2, 3, 4, 5 valence electrons, and so it can form 3 bonds and have 1 lone pair. That's going to be important in order to understand how this reaction works, knowing that it has that lone pair there and it can form these 3 bonds. Now, where these 3 bonds are pointing, we want to make sure that any branches we have are attached there. So we do have one branch, we know because it has that YL telling us this is a branch, and the prefix meth means there's only 1 carbon on that branch. So I'm just going to extend this out a little bit, and that's going to be a methyl group. So that's really a CH3 there in disguise, a methyl group. If you don't feel comfortable with that, go back and check out those videos on naming, with the naming table, with the prefixes and fixes and suffixes. That's the only branch we have. So what goes on the end of these other 2 bonds? Hydrogens. So we're just going to fill those in, hydrogens. This is methylamine. And what we're going to do is we're going to just dunk that methylamine, pour it into water. These amines, especially these small amines like methylamine, they smell like rotten fish. In fact, the smell of rotten fish comes from the amines in their proteins breaking down and being released as gases into the air. So this would be a clear liquid that would smell really, really bad. If you pour that into water, what happens? Well, you might see just a little bit of smoke, depending on how concentrated this methylamine was. But what's really happening there is an acid-base reaction. This lone pair on the top of the nitrogen can act as a base. Remember, bases accept H pluses. So this sort of is these electrons are sort of crackling with negative electricity, and they're going to try to rip a slightly positive thing off of whatever's nearby. And here, that's water. Let me draw water out so you can see this sort of happen, and you can get an idea of why you get the products you do. So that's water, H2O. It's bent. And what this is going to do is as this moves around in solution, it's going to move, twist, turn, smack into this, and these electrons are going to stick to this hydrogen here and rip it away from the oxygen. And that lone pair ends up turning into a bond. Now when that happens, the nitrogen gets a positive charge. It steals an H and a plus from water. So it gets the H and it gets the plus. And that is our first product. you'll notice the oxygen lost the H, it also lost a plus charge, and so it turns into our old friend hydroxide, OH minus. So those are the products. Let me redraw these reactants, how they looked originally, and so that we can see the change, contrast reactants with products. And so here you can see we started with methylamine, we poured it into water, and we ended up getting this ion and hydroxide. Notice the nitrogen has a positive charge now, and that's what makes this an ionization. This would be called an ion now because it has that charge. So when you put amines in water, the lone pair, let me just show you how this is going to change, and this change is going to be the same no matter what amine you have. That lone pair is going to turn into a bond with a hydrogen and a plus charge, and water will always turn into OH minus. So water will always be OH minus. So that's going to actually be the same no matter what the amine is. So no matter what amine I give you on the test, you'll always have this nitrogen with 3 bonds, lone pair. You'll always have water. The lone pair will always turn into a bond to a hydrogen with a plus charge, and water will always turn into hydroxide. And so the only difference, the only way that the test question can be different, or the other homework question can be different, is just in the structure of the amine. But that doesn't change. So it's really just a matter of drawing that and remembering how these behave when you dunk them in water. Let's see if you can recognize that pattern in another example. So in this case, they're giving us a different amine, dimethylamine, in B. So we have to draw that, and then we're going to be dunking it into water and drawing what happens. So let's draw dimethylamine. And when you see the word amine, you know that you're going to have a nitrogen with a lone pair and 3 bonds. What are they going to be to? What are those 3 bonds going to be connecting to? Well, it depends. What branches do you have? That's how different amines can be different. They'll have different things branching off of the nitrogen. Well, here we have branches. We see the YL, so we know that we have branches. What are they? We have 2 branches that are the same type. They're both methyl branches. That prefix meth means we have just 1 carbon there. So we're going to have 1 methyl group, a second methyl group, so this is a CH3, this is a CH3. What goes in the 3rd place? Because we don't have a 3rd branch, hydrogen. So that is dimethylamine. So with amines, the backbone is always named amine, and it represents the nitrogen, and the branches are always attached to that nitrogen. We're pouring this in water. That's always the case. And so we know we're going to get hydroxide, OH minus. Water is going to lose an H plus, so it'll become OH minus. That H plus is going to attach to this nitrogen here. So all you have to do is draw a bond where that lone pair was to a hydrogen and fill in that plus charge. Do you see how the structure of the amine is the only thing that's different here from the previous one, the example we did above? Otherwise, the lone pair turns into a bond to hydrogen with a plus charge, just like above. And the water turns into OH minus, just like above. So the only difference between these is really the structure of the amine. So amines do this all the time. Amines are really important. They're in neurotransmitters and hormones, and in a lot of medications also. Everything from, in recreational things like caffeine, for example, has amines, and this reaction happens anytime those medications or hormones or neurotransmitters are put into water. Our body is a bag of water with a bunch of stuff dissolved in it. So this process of an amine turning into these ions is a really common thing in living things. And so it's a process you want to be able to understand as we go into the biochemistry part of class.